and the switch rails, I use the term floating. Whatever term you want to use, they're not connected to anything. Hello, I'm James Ingram. This video was digitized from a 1992 videotape series named V9202. There's several references that can be referred to for this automatic switching system. The first we'll mention is this, back to this LGB Track Planning and Technical Guide 0028E. On page 129 of this publication, they have a diagram. It's figure 2 that shows the basic automatic switching system. Also, the German publication 0026N. On page 93, figure 2 shows the same automatic switching system. Going to the publication 0021 EPL Technique, on page 6, figure 4 again shows the same diagram for an automatic switching system. And finally, this November-December 1991 Volume 1, Number 4 issue of the Train Yard, on page 6, they had an article basically describing how to wire up the automatic switching system. Just bring it up in the view. This is basically the same system that's in those LGB publications I pointed out a second ago. Let's go back to the 0026N. Since it's got about the biggest, I just noticed the figure, and this is a little larger. Here's figure 2, which shows the automatic switching system. Basically what you've got is notice the direction is from left to right is indicated by this green arrow again. You've got two blocks, which in the actual publication are pink colored. They don't really show up on the camera, but they the on-off block in the what would be the right leg as you're going the direction of the train. The on-off block in the right leg is from here to here, and the on-off block in the left leg is from here to here. Basically what happens is, assume there's a train parked on this siding here. A second train will come down the switches coming through them straight. It'll go over a 1700 track contact, which is shown right here, and it'll basically throw the power over to this side so that this train will hit this now dead block and stop. The train that was waiting will pull out. At the same time, this switch will be set to curve back here, so the next train that comes in will be routed on this now empty branch. Now when the next train comes along, it'll be routed via the curved switch to this empty branch. It'll go over this 1700 track contact, which will throw the power back over to this side. It'll hit this now dead block and stop. Meanwhile, this train that was sitting here will pull out of the siding. And this is basically a flip-flop operation. A train will come in and stop. A train that was parked will leave. Another train will come in and stop on the now empty branch. The train that was parked will leave. It's basically a flip-flop operation. I think this will be more evident when we actually do the demonstrations. This publication, which is one of mine, P9105, basically describes the automatic switching system. What this has in it, basically there's some photographs here that shows what it looks like set up. You can see here probably even from the photograph, you can see one train coming in and stopping, and another train getting ready to leave. This is Tom Flynn's layout. We'll show this in video later in a few minutes. This publication has basically an assembly drawing in it that shows how to lay this unit out, the dimensions and parts call out, and it has a wiring diagram that shows how to wire the unit up, and also on the next page is a parts list that shows the parts required to make it. This basically, what's shown here is almost the same as what's in the LGB catalog, really with 3 deviations. The deviations I made from the standard LGB practice, which I'll try to point out when I actually show the unit, I've modified it so the front motor is not driving a switch on the front. It's slightly different in that respect. I've got 2 motors. I just use 1 motor. Let's go back to their illustration. Going back to their figure 2, they have a powered rear motor driving the points, and the front switch is just a manual switch. What I've done is I've basically taken the points off the rear motor, so the rear motor drives only the switch. I've taken and added a second motor up here, which drives the points, but does not drive the switch. Back to the old same issues with the automatic blocks, trying to increase reliability by putting the minimum load on each motor. The way I've modified it, this motor, instead of driving points and, that is, instead of driving electrical points and the switch, just drives the switch alone. Then there's a second motor up here that just drives nothing but the points, and the engines just push the switch to whatever direction they need to go. So going back to these deviations, which again I'll try to point out on the actual unit to make it more clear, but number 1, the front motor is not driving the switch. I've got a front motor just doing nothing but driving the points. Number 2, I've added a rheostat for startup voltage control on my units. Number 3, it's a modular design. It's all pretty much in one unit, so it can be moved around and set up fairly quickly. This is the wiring diagram, which is almost the same as the one in the publication. I've modified this wiring diagram to add the rheostat. I call it a model 122 when it's got a rheostat. When it has no rheostat, I refer to it as a model 121. They're almost identical. The model 121 has no rheostat. The model 122 has the rheostat. If you build the unit as described by this publication we were looking at it a minute ago, the P121, what you end up with is essentially the hardware configuration is shown on the floor. Here's your front converging switch and your rear diverging switch. Direction of travel is from left to right as indicated by this engine. You've got to use your imagination a little bit. This branch here would go out and connect to this branch here and come back in. Then this would be the straight branch here. I just kind of squished this together to make it a little more compact to fit in the camera. And again, as shown, as this thing's built now with the rheostat on it, I call it a model 122 because it has a rheostat. If you use these plans in the publication here, you get exactly the same thing minus the rheostat, which is the model 121. And what I did when I built this thing, I originally built it like this, then later decided I wanted a rheostat, and so I added the rheostat later. It's perhaps appropriate to discuss that there's 2 modes of operation this automatic switching system can be used in. One would be, as it's shown set up now, would be automatic passing sighting, which is the way it's shown in the LGB publications, where it's basically a passing sighting where one train comes in and stops and the other one takes off. The other use, which we haven't talked about much yet, is automatic route selection. This is where you reconfigure this switch so you can actually cause trains to travel different routes. I don't really recommend building this unit as I build it. It's kind of a messy thing. You can see you've got the basic, the main switch unit is here, then you've got your 1015U's here, your track contacts here, and finally your rear diverging switch back here. It's a little messy. You can see there's a lot of wire hanging around. I'll show a later design with the automatic switching block where I put essentially all this stuff here on one board. It's a lot more compact and a lot less messy. Now there's basically two reasons you might want to build it in the messy form like I've got it here, nevertheless. The first of those reasons you might want to build it messy like this is simply it's compact. This thing all basically can go in a box just about 24 inches long. I forget what the dimension on that thing is. Yeah, that's a 24-inch long board there, so this thing will fit in the box slightly more than 24 inches. So one advantage of this messy design is that it's compact. The other advantage of this messy design is it can be reconfigured many different ways, including automatic route selection if you want to use that. Let's take a look at this publication P8811. I'll call this switch here where the main unit is, I'll call it the converging switch, referring to it as converging because the two tracks converge together at this switch. Just looking at some of these track plans in P8811, you can see this is layout number, what I refer to as layout number 3. Here's your converging switch here. This is actually used for automatic route selection on this layout. The track diverges here. Each track goes its own way and it converges here. These track plans all use trussels. That's why when you view them from the top view like this, it looks like there's tracks going on over top of tracks, which is the case, in fact, as accomplished by trussels. Layout number 4, more of the same thing. Here's your converging switch here. It diverges over here with the other switch to accomplish automatic route selection. Layout number 5, more of the same thing. Here's the converging switch. So you can see the thing leads in differently. So to build all these layouts, you almost need that messy configuration like I've got on the floor. Here's layout number 6. Here's your converging switch. You can see the thing is built as an automatic passing sighting configuration, but it's actually built on a corner for compactness. This layout is only 12 feet long, and you don't really have enough length to make a straight automatic passing sighting. So here's your diverging switch. Your passing sighting starts here at the diverging switch and actually finishes on a corner. Again, if you built this thing longer with the legs intact and screwed down straight like you normally would, you wouldn't be able to do this trick with it. Here's layout number 7, and note again here the converging switch, we've got tracks coming in a different order, or I should say in a different configuration. Finally, layout number 8, again that same automatic passing sighting built on a corner. Some more comments on the construction of this unit. The rheostat, I really haven't told why I added that thing. Basically, the purpose of the rheostat was to allow the ability to reduce the starting voltage. As you saw a moment ago from my track plans, I sometimes mount it on a curve, and the problem I had was when a train was starting up on those curves, it would tend to sometimes derail the cars just from the engine pulling suddenly with the full track voltage against the train on a curve. So with this rheostat, again, it's that same 0 to 10 ohm rheostat. With that rheostat, you can reduce this voltage on these blocks so that when the train starts up, it doesn't get the full track voltage. It gets the track voltage minus whatever this thing is set at, so it starts out a little bit more gently. That's the purpose for the rheostat. Notice the front motor up here is physically disconnected from the switch. At one time, I had this motor driving the switch. To make it more easier to troubleshoot and reduce the load on the motor, I moved the motor off the switch so it sits over here by itself, and all this motor does is drive the points. And the switch rails, I use the term floating. Whatever term you want to use, they're not connected to anything. These switch points can just move by themselves. Basically, how it works is when the train comes the engine comes through the switch, it just pushes the points to whatever direction it needs to. Then when one comes from the curved side, it'll push them back the other way. And back here, this switch has the normal 1201 motor on it back here that's driving that switch. Here you've got the ever-present knife switch to power and depower this thing, and an indicator light to indicate that it's getting AC power, and your two track contacts and your two 1015Us. Your block is from here to here in this leg, and from here to here in this leg. If you study this, these construction drawings, this booklet, you'll notice the gap on this thing is in the left rail, which is inconsistent. Everything I've been building that I talked about up to now, I put the gap in the right rail. It really doesn't matter which rail the gap is in, as long as it's consistent. And these were early. I built this unit back several years ago when I did it in the left. I've got the gap in the left rail. If I was redoing this, I'd put the gap in the right rail just to be consistent with the other units. What these wires running back here are, these gray wires, they're basically, I guess you could call them jumper wires, just to maintain continuity from the front of this block to the back of this block. In other words, from this rail here across the block to the rear of the block, you've got electrical continuity via this gray wire. Likewise on this side, from this rail in front of the block back to this rail behind the block, you've got continuity via this gray wire. Those automatic blocks that we were talking about earlier, if you study those real closely, I actually break the, in the case of those, I break the right rail. There's really a discontinuity across the block unit in the right rail. I depend on the power in the right rail from coming around the other side of the block and coming in the back, so to speak, behind the slowdown section. You actually could put a jumper on those blocks, although I usually don't, just to avoid having a long, messy wire hanging around. In this case, since my block is relatively short here, it's easy to run these jumper wires and have electrical continuity across the block. One other comment to make about the placement of these 1700 track contacts. Notice the block will be from here to here in this leg, and from here to here in this leg. And the thing I want to point out is, notice the track contact is behind, or let's say, well, it's to the left of the block in both cases. In other words, the locomotive will travel over the track contact, then it will get to the block section. One thing you do not want to do is this, have these things inside the block. I did that once and it sort of works, but the problem is when the engine goes over the track contact and throws the power over the other side, it's going to stop, and sometimes they'll stop on top of the track contact, in which case the engine is sitting there holding the current on the switch motors, and then the train tries to come in the other side and nothing happens because this engine's sitting here on top of the track contact, putting continuous current on these switch motors, and it essentially jams the whole thing, so to speak. So do not put these track contacts inside the block. Make sure the track contact is back here to the left of the block, so the engine will roll over the track contact, throw the power over to this side, so this block will be dead up here, but the engine will still have a live rail, so to speak. It'll have power to move off this thing, then it'll go down and into the dead block and stop. So your engine will stop down here and definitely pass over the 1700 track contact.